This is a high-level overview of what I have accomplished so far for my project about simulating hair, specifically with position-based dynamics. I want to say before I start, I initially tried a completely different approach, which is modeling each strand individually, and I got to the point where I was adding more complexity in the environment with things like wind and inertia, and rendering all of those strands with nothing but a line renderer got super taxing, and the simulation slowed way down. So I switched my perspective, or my approach rather, to use a guide strand with children. It's basically a self-similar structure that builds itself into multiple patches composed inside of one patch. You'll see more about what I mean when I show the inspector. So the position-based dynamics hair patch script is mainly in charge of controlling the vast majority of options. Basically, like I said, each patch is composed of a customizable number of guide strands. Here in the screenshot, it's 20, with 5 children per guide. So this will give a pretty spread out layout because there's only 5 children per each 20 guide strands in the entire patch, so you'll be able to see the object below it. But if you were to jump the guide strand count all the way up to 100, it would be super dense, more like fur of an animal. And you could increase the size, the width of these groupings to make it look however you want, really. It's very customizable, which is the main goal of my work so far, is creating very customizable fur, or fur, hair, whatever you want to use it for at different lengths, and it all still behave normally under different circumstances. So the render settings control the material of the strands and the width parameters and stuff like that, what color they are, what they look like. The patch layout allows tweaking different things like the density of everything, the size, format settings, the total extension of the patch, how big it is. If you need to tessellate a larger area, instead of using multiple patches, you just want to use one, you could just increase the how far it extends, the patch extends. The actual shape of the strands are more concerned with the actual individual hairs. So that's how many particles are modeled per strand, how many control points, essentially. And then the minimum, maximum length, the length randomness, like how much is that going to affect it. You can basically look at all of the different things here, like bend stiffness, shape stiffness. This is all because I was running into issues where the movement of the strands was very uncontrolled, flying around crazy. You need a lot of clamping, so you need to set things very specific, lots of parameters. And then finally, what I added last was external responses: gravity, wind, inertia, angular inertia. So this is like as an object is moving, or as you crank up the wind in an environment, or as you change all of those things, how much does it affect each patch? Do you want, and this can be used later to model things like wetness, where a wetter patch would be a darker color and not move as much, not respond as much because it's heavier. So these are a lot of parameters that are going to be super useful in my future work. And this is just the hair system script that controls the total character. Basically, it's like the direction of the wind, the strength, the turbulence, the larger environment factors that are taken into account at each patch. So each patch looks at this for the wind direction, the strength, and stuff like that. And also, super important part is the simulation substeps and constraint iterations. This creates really controlled movement where you're not just updating once every step, you're actually updating 3 times per substep, and that's customizable. And the constraint iterations essentially bound the movement of each strand, so you don't get jumping around, you don't get tips teleporting around and flinging crazy, because they're constantly bounded 6 times per step in this iteration, or in this implementation, So that's a pretty high level overview of kind of the driving forces of the code. And in the future, I just kind of want to improve the total environment setup, the complexity of it, and get better results for the final video with like wetness and being able to tessellate an object at different points. You have top fur, bottom fur, side fur, stuff like that with different conditions. That's kind of where I'm going with that. And since I don't have much time, I'll just jump into the demonstration real quick. I've got a couple cameras set up just on moving objects. So the first camera is just a side-to-side. You can see that the one on the far right is much more affected by wind. It has the wind strength turned all the way up, so you can see some stray movements within the angular movement. And the wind is pushing left to right. So that's why even when it's moving in a certain direction, like when it's moving back here, it's still being pushed a little bit to the right. This gives you kind of an idea of how different environments could look in the future. And if I switch to the first display, this gives a better idea of how the hair is actually generated. So you can see on the left, this one has way more guide strands with a ton of children per guide. So you get a thicker density and also thicker guide strands because there's more children per guide. This one is more standard. It's pretty light, but it doesn't have any wind on it and very low inertia. So it's very stiff and it's just moving back and forth almost perfectly with the object. This one is a longer implementation with a lot of wind and inertial direction on it. So this is just basically to see the calmer movement that is being bound by the constraint iterations and the substeps, simulation substeps. I feel like if I'm trying to model something like an animal, I would probably go more with the settings of the one on the far left, just because it's denser and looks more like fur, where you could also model something like grass, like long, tall grass, or some kind of plants or something like that. But I have found it very interesting how this forms basically a self-similar structure, because each patch is formed up of its own patches that have their own settings. So I think it's pretty interesting, and I'm looking forward to expanding on this idea.